Hello everyone, welcome to my class. In our earlier classes, we have already discussed about moment of force. So today we are going to discuss about couple. So without wasting time, let's start the class. Students, in our earlier classes, we have already discussed that moment of force is nothing but the product of magnitude of force and perpendicular distance. Okay, what is this perpendicular distance? As you have already discussed, perpendicular distance is nothing but the distance of the body to be rotated from the pivot point. Okay, now is it true that a body can be rotated with a single force? No. For example, when we take the example of a door. Okay, so what happens? The door actually it rotates about its hinge. So this is the door, suppose this is the handle. Okay, this is the handle of the door. We put the force or apply force at this point and the door rotates about the hinges, those are attached over here. Okay, so what happens now? The moment of force is nothing but the magnitude of force and the perpendicular distance. Suppose this is the perpendicular distance from the hinge to the handle. Okay, this is distance. So moment of force is nothing but F into D. Got it? So we have a moment of force at this point. But what about at the hinge? At the hinge, as the distance is 0, isn't it? The perpendicular distance is 0. There is a reaction force of the same magnitude of F. Suppose this is F1, this is F2. A reaction force F2 is acting at the hinge that is of same magnitude as F1. But the moment of force at the hinge is 0. Why? The perpendicular distance, that is D, is equal to 0. Where? At the hinge. So as the perpendicular distance is 0, so the product gives us the 0 value. So moment of force at hinge is 0. But there is always a reaction force acting at hinge that is of same magnitude which we apply at the handle. Okay, so we need to remember that we cannot rotate a body with a single force, but there are always two forces acting at the same time. One is the action force and the reaction force of same magnitude. Okay, the direction of the forces are parallel. Okay, we need to remember that the action force and the reaction force, they are, suppose in this case F1 is the action force, this is action force, and F2 is the reaction force. So we need to remember that these two forces are parallel to each other. Okay, so two different forces of same magnitude but acting parallel to each other are called a couple. Okay, so how can we define couple then? A couple can be defined as two equal and opposite parallel forces not acting on the same line. Okay, they form a couple. Students, from the discussion in couple, we come to know that the pair of forces, those constitute the couple, they act in the opposite direction, parallel to each other, and they have the same magnitude. Sometimes when we need greater amount of turning effect, then equal magnitude of force, opposite directions are acted upon explicitly on such parts of the body so that the body rotates in the same direction. For example, as you can see in the diagram, it's a wrench that is used to move the car wheel from the car. So in such cases, what happens? The force is applied in opposite handles of the wrench, as you can see in the diagram. So what happens when we put the force in opposite direction with same magnitude, the wrench rotates in the same direction. Isn't it? See, one force is applied in this direction and another force is applied in the downward direction. So the magnitude is same and the range, it rotates in the same direction. See, it is rotating in clockwise direction now. Okay, so this happens to the range with the application of the couple. We can have some more examples like opening a tab or opening a lock using a key. In these cases also the same thing happens. Okay, hope you understand. Students, let us now discuss about the moment of couple with the help of this diagram. Okay, here you can see there is a bar AB. Okay, AB is a bar and the center is O. Okay, center is O. That means AO is equal to BO. And AB has a distance of suppose D. You can clearly see that when we need to rotate this bar which is pivoted at O, we need to apply a force F in opposite direction. See, this is upward direction, this is downward direction. Now you can see that both the forces, when they apply, the bar rotates in anti-clockwise direction, isn't it? The bar rotates in the anti-clockwise. This is anti-clockwise direction. But the application of force are upwards and downward. They are opposite, but magnitude is same and the direction is opposite. So what is happening? The bar rotates in a anti-clockwise direction. So as the body is rotating, let us now find out what is the moment of force at the ends. That means at A and B. So at A, moment of force would be F into OA. This is the perpendicular distance, and at B it is F into OB. Okay, so total moment of force is equal to F into OA plus F into OB, that is F into OA plus OB. What is OA plus OB? That is nothing but D, isn't it? So it is F into AB, or which we have represented as D. So F into D. So moment of couple can be defined as the product of force at either end. Why either end? Because they are same. So force at either end and perpendicular distance between the two forces. This is the perpendicular distance which is represented by D. So perpendicular distance between the two forces. Hope you understand. Students, we have now discussed that moment of couple is equal to force multiplied by distance. That means the perpendicular distance. Okay, which is also called the couple arm. So what should be the SI unit then? The SI unit of force is Newton and that of distance is meter. So Newton meter is the SI unit for moment of couple. So let us now discuss an example related to moment of couple. Okay, students, suppose there is a bar AB of length 2 meter and we need to apply 2 Newton of force upwards and downwards at two endpoints of the bar. So as you can see in this diagram, force of 2 Newton is applied at point A downwards and same force of 2 Newton is applied at point B upwards. That means they are acting vertically opposite to each other. So what should be the moment of force at center O? So in this case AB is equal to 2 meter. That implies OA is equal to 1 meter. OB is equal to 1 meter. So what should be the moment of force at A? Moment of force at A is equal to F into D. So that is 2 Newton into 1 meter, that is 2 Newton meter. And moment of force at B is equal to F into D, that is again 2 Newton into 1 meter, that is 2 Newton meter. So total moment of force, that is equal to 2 Newton meter plus 2 Newton meter, that is 4 Newton meter. So this is the total moment of force at center O. What we have already discussed, that moment of couple is nothing but the product of force applied at either end and the perpendicular distance between the two sides. Let us find out what is the moment of couple then. Moment of couple, that is equal to force at either end, that is 2n, into distance, that is 2 meter, that is 4 Newton meter. They are actually equal. The moment of couple is nothing but the total moment of force at the center of the bar. Okay, hope you understand. Students, today we have discussed about couple and moment of couple. Hope you have understood everything clearly. If not, please watch the video again and go through the book. You will understand everything clearly. Okay, so you need to practice a lot, you need to revise, which will help you to remember all the concepts you read. Okay, so keep revising, keep practicing, and most importantly, keep smiling.